Hi there, Greg Perkins back. Here we go for the Chapter 5 overview. So first of all, given this distribution, is it a probability distribution? Well, there's basically two requirements. One is all of the probabilities need to be between 0 and 1. With these all being 0 point something, it passes that part. The next thing you have to check is that when you add these up, it adds up to 1, or in other words, 100%. So the sum of the px's equals, let's see, 0.3 plus 0.1 plus 0.2 and 0.1 and 0.3 equals a 1.0, so it passes. So each probability is between 0 and 1 in decimal form, and they add up to exactly 1.0, or in other words, 100%. Next, find the mean for the random variable. So what we need to do is multiply across So basically it's saying something like a 5 shows up 30% of the time. A 4 shows up 10% of the time. So that means the 5, since it shows up more, it should count for more. Well, when you multiply these two, you're saying, well, I'm going to win $5 30% of the time, so that's worth $1.50. I'm going to win $4 10% of the time, so that's only worth 40 cents. So this is worth more. It's called a weighted mean. Anyway, so then the mean, and since this is the mean for the whole situation, since this is 100% of the possibilities, this is not just a sample, so we don't use x bar, we use mu for the whole population. So in other words, 1 through 5 is the whole population. So we would just have 1 times 0.3, 2 times 0.1, 3 times 0.2, 4 times 0.1, plus 5 times 0.3. So 0.3 plus 0.2 plus 0.6 plus 0.4 plus 1.5. So the average is 3. And in fact, it turned out to be 3.0. Next, for the standard deviation. So the formula for the standard deviation is that it's the square root. You add up the x squares times the probability of x, and then you minus the mean squared. So it may look a little bit scary, but it's not bad at all, because all you have to do is square each one of these numbers, 1, 4, 9, 16, 25, then multiply across, then add them up, and subtract a 3 squared. At the end, we take the square root. So it's going to be, you know what I'm going to do? I'm going to break off this part and do this part first. So it's going to be 1 squared times 0.3. So just going back to these numbers, 1 squared times 0.3, 2 squared times this, and we're going to add those up. So 1 squared times 0.3 plus 2 squared times 0.1 plus 3 squared times 0.2 and 4 squared times 0.1 and 5 squared times 0.3. So this is going to be 1 squared is 1 times 0.3 plus 2 squared is 4 times 0.1. The next one, 3 squared is 9 times 0.2. Next is 4 squared is 16 times 0.1. and 25 times 0.3 for the last one. 11.6. Okay, so now let's get back to the whole formula. So this part in red is going to be 11.6. So we have the standard deviation is equal to the square root of 11.6 minus 3 squared. And then we just need to take the square root. So the square root of 11.6 minus 3 squared, or 9. The standard deviation, 1.612. Wow, this one's going fast. It's a fact, at least according to the Google search I did, it's a fact that 10.6% of teens smoke cigarettes. Suppose that a group of 20 were chosen. So this setup is saying that the P is equal to 0.106 and that the N is equal to 20. So that is screaming, this is a binomial situation. Binomial means two possibilities. They either smoke or they don't. I know in real life it's not that cut and dry, but in math it is. In math, you're considered a smoker or not. It's basically how the people answered. Did they say yes or did they say no? Find the probability that exactly 3 of these teens smoke. So we could do the binomial formula. It's going to go like this. The probability that x equals 3. So I'll do the binomial formula itself once, but then I'm going to be using the calculator after that. So the binomial formula goes like this. You've got 3 smokers, so the chances of being a smoker is 0.106, and you've got 3 of those. Well, if 3 of them are smokers, then 17 of them, because we have 20 people, so these two have to add up to 20 people, 17 are non-smokers. Well, for a non-smoker, that would be 1 minus the 0.106, the chances of being a smoker. So for non-smokers, the chances are 8, 9, 4. So we have 3 smokers and 17 non-smokers. But if I only did this, that would mean the very first 3 people are the smokers, the other 17 people after that are the non-smokers. Which of course it doesn't have to be like that, it could be any combination of people. So what we have to do is say, take all combinations out of 20 people standing around, you want 3 of them to be smokers, and then multiply. And that is the binomial formula. So we're going to use the calculator to multiply this out. So first of all, we would have 20, and then go to math, over here on the left side. Move over to probability, and then combinations, and then a group of 3. So that's 1140. Now we need 1140 times 0.106. That's raised to the 3rd power. And then 0.894, and then that one is raised to the 17th power. So it would be 20.2% chance that exactly 3 of them are smokers and 17 are non-smokers. Instead of doing this binomial formula, you could have the calculator do it. On the calculator, it's called binom for binomial, probability, distribution, function, or PDF. And then what you have to put is the N, the P, and then the X that's wanted, X equals 3. So this is in a slightly different place in the calculator. It is right here under distributions. So you have to put second distributions. It's about the 9th or 10th one on the list. Okay, the 11th. Binomial PDF. Then hit enter. depending on the version of your calculator, this is one of the newer versions, you have to put the trials, which is the n, the p-value 0.106, and the x-value is 3, and then paste. If you have an older version of the calculator, then when you first went into Binomial PDF and hit enter, it would just put this and leave and put a blank right here, and you just put the 20 and this yourself. Not really much different. Anyway, like before, the answer is 0.202. Now find the probability that at least 3 smoke. So with 20 people, it could be that none of them smoke, or 1, or 2, or 3, or 4, or 5, etc., or 19 to smoke, or all 20 of them are smokers. I'm asking for at least 3. So I'm asking for all of these possibilities. Unfortunately, the calculator doesn't have a function that could just add those cases up for you, because you basically need to do the binomial formula with x equals 3, x equals 4, x equals 5, etc., until x equals 19 and x equals 20, and then add those up. Well, what we could do is we could do the opposite, and the calculator does have a function to add those up. And then for this side, it's going to be 1 minus the opposite. So here's what it would look like. The probability that x is at least 3, so that's the original question. And instead of doing that, I'm going to do 1 minus the opposite. And then the opposite of at least 3 jumps us over here. That means it's less than or equal to 2. And then for less than and equal, the calculator does have that. That is done with binomial. Instead of it being PDF, it's CDF. And the C stands for cumulative. In other words, start at 0 and accumulate values all the way up to 2. So then you just have to tell it that n, which is 20 people, the p, which is still 0.106, and then add up all the way till 2. So we need the 1 minus first of all, and then second, distributions. Get the binomial CDF, and then it's out of 20 people. P is 0.106. The x value, we're going up to 2. And so it still has the 1 minus and then the binomial CDF. So a 357, or in other words, 35.7% chance, at least 3 of those people would be smokers. Okay, on to number 3. A couple wants to have 5 kids. I've heard that story before. X is going to be the number of boys. Create the probability distribution table. So X and the associated probabilities is what I'm asking you to do. Well, if they're going to have 5 kids and X is the number of boys, the smallest X could be is that they have 0 boys. They might have 1 boy, 2 boys, 3, 4, can I make it? 5. And since there is a 50% chance of having boys, that means this is a binomial situation because it's a person is a boy or they're not. I realize in real life there are ambiguous cases, but let's just say someone is either a boy or not. So it's the binomial situation, so we're going to be using the binomial formula again. Distributions, binomial, and we just need one at a time, one case at a time. So the trials is going to be, they're going to have 5 kids. The chances of boy is 50%. And then we're supposed to plug in 1 time x equals 1, write that down. Then x equals 0, then write down that answer. Plug in x equals 1, then write down that answer, etc. and do that for all of those. Well, if you don't tell it what to put for that last number, the x, what it will do is do all of the possibilities for you all at once. So this is when x equals 0, this is when x equals 1, when x equals 2, etc. So the first one was 0.031, the next one was 0.156, and then 0.313, and then to see the other ones, just use the right arrow key, and it will scroll over, and then it's 0.313 and 0.156, and the last one, 0.031, which actually makes it pretty much a nice bell-shaped curve, because when you've got 0, that would be a small probability. When you've got 1, it's 156. When you've got 2, it goes up to 0.313. When you've got 3, it's still the same. And then on the other side, it's symmetric. And so it makes a normal distribution or a bell-shaped curve. And then on to number 4. It's a fact that 26% of men in the United States are 6 feet tall or taller. Don't you just love Google? Thanks, Google. Suppose that 400 US men chosen at random. So this is going to be P equals 0.24. This is going to be that N equals 400. So that's a binomial situation. Well, to find the mean and the standard deviation, the mean, the formula is that it's just N times P. So just multiply those two. So on average, 24% of 400 men, 24% of means multiply, 400 would be 96 men. Then the standard deviation. So standard deviation, sigma, the formula is very easy. It's the square root of N times P times Q. And the Q is 1 minus the P. So in other words, Q is going to be 1 minus 0.24. So that's 0.76. So back to the formula, it's going to be the square root of 400 times 0.24 times 0.76. So the square root of 400 times 0.24 times 76. The standard deviation, 8.542. Beauty. And finally, would it be considered unusual? So this is a key word saying if you go out 2 standard deviations. So if I take, oh, excuse me, I misread. It's still unusual, but I misread the question. Hold on. Would it be considered unusual if 150 men... Oh yeah, I didn't misread it. Forget about when I said I misread it. Unusual means you go out 2 standard deviations. So if you start at the mean, so in other words, we would expect 96 men to be 6 foot or whatever, 6 foot tall or taller. But then if you add on 2 standard deviation, that gives you the upper cutoff. So take 96 plus 2 standard deviations, and that gives you the upper cutoff for what's considered a lot of men being that tall. So 96 plus 2 standard deviations. So the cutoff is 113 men. 113.084. So in other words, if there was a meeting of 400 men, on average you would expect about 96 of them to be tall. at the uppermost, there's probably 113 that are tall. This is saying, what if you had 150 of them? I'd say then you're at some type of basketball situation because that's pretty unusual. So yes, 150 is unusual. Unusual. Okay, that's it for Chapter 5.